Let's now talk about what's called measures of central tendency. Really, what this is saying is if you have a data set or a variable where you have data for that variable, um, really it's sort of trying to look at, what's one number that can kind of summarize that variable. So, for example, let's say you've gone around asking people their income. So you have a data set where you just have basically a bunch of numbers that each number represents a person's income. And so what can you do? What's the sort of center of that data set, right? What's the center of that variable? That's sort of what this is getting at. Now, the three sort of measures of central tendency, mean, median, and mode. Let's first talk about the easiest one, mode. Mode is just the most frequent observation. So the modal income is the number that's the most common. So mode is just most common. The median is the one right in the middle when you arrange them in order from smallest to largest. That second part, the arranging in order thing, is the thing that most people sort of leave off. But yeah, so this is the middle, the literal middle number. And the mean is just the average. All right, so let's just, for example, let's say you've basically asked 5 people their income, and let's say it's measured in thousands of dollars. Let's say the incomes are 0, 20, 50, 80, and 100, right? You know what? Let's say this is 80. There's two 80s. Okay. So, first of all, what's the mode? Well, the mode is just the most frequent observation, and that in this case is just going to be 80 because that's the only one that there's two of. What if there was only one of each? Well, then technically every number is modal because, every number is technically most frequent if it's just once. The median is the one right in the middle. Notice here I've arranged them in order. If these were not in order, you'd have to do it first. Because otherwise, if they're not in order, technically you could just move the numbers around and then you'd get a different median, right? And that sort of doesn't make sense. Like the median shouldn't depend on the order in which I ask people the question. And so overall, what's going on is that once you put them in order, the whole point, the median here would be like right here. The whole point of the median is that at least that half of the people have at least that value, and the other half have at most that value. So it's really just splitting the participants in half and saying half the people have a number greater than this, the other have a number less than this. Now notice that here the median is sort of tricky because there's an even number of numbers. If it was odd, like let's say now that we didn't have this 80, if it was odd, then just the middle number is this guy, 50, right? Because there's 2 here, and so the middle number is 50. If there's an even number like this, then there's basically 2 middle numbers, and all you do is you just average them. So the average of 50 and 80, would be the median. So the median would just be the number in between the 2 middles. So anyway, here we have this data set. We have its median. And for the mean, we just add them up and divide it by how many there are. That's essentially how you find the average. The way to find the average, again, add them up, divide it by how many there are, and that gives you the average. Now, importantly, the whole point here of why you should sometimes use the median instead of the mean is this. Let's say, you were asking 5 people their income, and you were taking the mean, the average, right? Add them up and divide it by how many there are. What if the 5th person you asked, right? Yeah, you're asking 5 people, these are 4. What if the 5th person in your sample was Bill Gates, and let's say he had a $10 billion income that year? Well, now if you were to find the average, you're going to add up these 5 numbers, divide it by 5, and your number is still, it's going to be pretty close to 2 billion. So the mean income is $2 billion, but that's not really helpful for us. So the point is this: whenever you have outliers, the mean is sort of skewed by them. The mean is influenced by outliers, but the median is not. Here in this data set, even with this 10 billion, even with Bill Gates in your sample, the median income is still 50, because that's still the middle number. So the point is that the median is not influenced. So the median is not influenced by outliers. So not influenced by outliers. And so notice here also that if you were to find the mean, and the mean is like 2 billion roughly, well, notice that just because it's the average doesn't mean that people are close to that number. Not only that, here only 1 in 5 people is actually above the mean. So that's sort of one thing. When people talk about income, so here, now let's actually specifically talk about income, and why income is usually a really weird thing. It's one of the most common things that we measure in policy. But, the modal income, the most frequent income, you know what the modal income is? 0, which is weird. But not so much if you think about it, because people report their income like to the dollar, right? If you think about the most frequent observation, for somebody to make exactly $35,484, I mean, there's not going to be a lot of people with that exact same number to the, to the units digit. If you were to round it to the thousands, then 0 is not the modal income, But just looking at the pure numbers, the most common number is 0, just because anyone who's unemployed has that income. So mode is a bad measure if you're looking at income. Mean is similarly not as good because the billionaires essentially pull the average, the mean income up to the point where it's not as useful because less than half of the people have an income that's above the mean, that's above the average, just like we saw here. The average is 2 billion, but not everyone, very few people actually have a value close to, let alone above, the average. But the median is sort of impervious to that because, it's sort of measuring the thing we usually want to measure, where it's like, all right, where do people lie? Where do most people lie? Or at least people being above or below a certain measure. So the median is usually good for income. But as far as most of our actual statistical work goes, we usually tend to use mean. It's easier to work with a bunch of other stuff. But the important thing to keep in mind, what's the whole takeaway for this conversation? If somebody's talking about some policy and blah, 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 and the average, and you're a bit skeptical that all this will check out, just one question to ask is, does the analysis change when you use the median instead? And if the answer is no, well, then it's a pretty robust thing. But if it does change, well, that's something to think about. One point on the mean. You'll often see this formula for it, that x bar is equal to the sum of xi over n. Now here, what exactly does this mean? This is basically complicated looking notation for something that you already know how to do. This is just saying add up all the x's, all the observations, and divide it by how many there are. So for example, let's say you have n equals 5 observations. The way this summation operator thing works is just saying whatever's over here next to the summation is the representative term. That's a thing that's being added. This whole summation by the sigma just means sum, meaning adding. So you're just going to add this xi to itself a bunch of times. And the only thing that's going to be different from term to term is the index, the I. It starts with 1, so this is basically, when a mathematician sees this formula, this numerator is basically x1 plus x2, and so on, right? Because xi, meaning x with some subscript, that's the representative term. That's what each term here is, being added, starting with 1 and ending with whatever n is. And here n is 5, so ending with 5. So x1, 2, 3, 4, and 5, right? x5. So you essentially add up x1 through x5. And what is x1, x2, x3? These are just, x1 is the first person's income. x2 is the second person's income, and so on. So you add the 5 people's income, and then all that divided by n, which is just 5 in this example, So that's all this is. Whenever you see this formula, that formula is just saying add up all the incomes and divide by how many people there are, and that gives you the mean.